Okay. So, last class we derived that junction effect. If I consider that vocal tract is nothing but a junction of several tube and if the cross sectional area across the tube is different, what should be the junction effect we have discussed. Now, if we said that if each tube has a fixed length del x, then this tau, the delay line tau can be represented by z to the power minus 1, because z to the power minus if the T 1 is equal to tau. Okay. So, this is the single junction kth junction signal flow diagram. Now, if I consider the same, if the tube has n number of sections. So, suppose I have a tube length is L and I cut this tube in n number of section. So, the length of the each section x is equal length L by n. So, tau is nothing but a x by c. So, it is nothing but a tau is nothing but a x is nothing but a L by n c. So, if I have a tube of 17.5 second, let us say 5 centimeter tube long, and if I divided the tube in n equal to 10 junction, then the tau is nothing but a 17.5 centimeter divided by n into c. C is the speed of the sound, that much of delay is required. Okay. Now, I come, if my tube is n number of tube is there. So, there will be a n minus 1 or the junction 1 to n minus 1 number of junction. So, I can draw the equation like this way. This is u g n, then the first junction, second junction dot 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 n minus 1 junction, and this is the, and if you see the last one is the boundary condition at lips and this one is the boundary condition at glottis. So, it is R g, it is half of 1 plus R g, it is minus R L, 1 plus R L. I can draw the n tube equivalent signal diagram, signal flow diagram, and each delay is represented by z to the power minus 1. Okay. Now, if this is my tube, let us u g n is nothing but a delta signal, delta n, okay, delta signal or delta n. If it is delta signal, then output, if this is my signal flow diagram, then output I should get V a t at the output is nothing but a B 0 delta t minus n tau plus k equal to 1 to infinity B k delta t minus n tau minus 2 k 2 tau. Why? So, if you see, if I have a tube with n number of junction of length, let us n, the n section of junction. So, each section create a delay tau. So, n section create a delay n tau, but that is the first signal, first delta, that is why B 0 into delta n. But after all the signal, after the first round, the delay will be there. So, what is the delay? 2 tau is the round trip delay. So, this is the first arrival of the signal. Second will be arrival due to the back propagation. So, there will be a 2 tau delay. Okay. So, earliest arrival is n tau, which is n number of tube, each section delayed by tau. Next signal will come by 2 tau delay. So, I can say next signal will be integer multiple of 2 tau delay. So, that is why I said k 2 tau, k into 2 tau, k is the integer and 2 tau is the delay. Okay. Now, if I consider, to avoiding the aliasing of digitization process, if I consider my sampling period t is equal to 2 tau. So, my sampling period t is equal to 2 tau. What I am saying, suppose I want to create a band limited signal or less pitch signal whose maximum frequency is 500 hertz, 5 kilohertz or 5 kilohertz. Let us 5 kilohertz is the maximum bandwidth. What is the sampling frequency? 10 kilohertz. 10 kilohertz is the sampling frequency. So, band limited is 5 kilohertz, Nyquist criteria is 10 kilohertz. Okay. So, if I want to reach the Nyquist criteria in this 2 tau delay, so 2 tau must be equal to the sample period. Okay. So, 2 tau is equal to sample period. If 2 tau is equal to sample period, then how do I derive this Vz? If I consider this is a z domain, Vz which is nothing but a ulz divided by ugz. Okay. And each z to the power minus 1, now z to the power minus 1 is single sample delay. Now, my sample delay is t equal to 2 tau. So, I can say instead of z to the power minus into minus 1 into z to the power minus half. So, all the z value will be replaced by z to the power minus half, z to the power minus half, z to the power minus half, z to the power minus half. So, I get this signal flow diagram. Once I get this signal flow diagram, can I derive the Vz transfer function of the tube, which is nothing but a output, which is uz, ulz divided by ugz, z domain. Okay. So, ugz I know it is nothing but a impulse or Gödel response. Now, what is ulz? So, I have to derive this transfer function. So, how do I derive it? Using a signal flow diagram I can derive it. So, there is a procedure for derived it. So, let us use some procedure or use some simplest this may be the simplest form procedure for deriving the transfer function of Vz, which is nothing but a ulz divided by ugz. How do you derive it? If I consider each one of the junction is acts as a lattice, if you see the symmetrical, this is R1, this is R2, this is Rn minus 1, but all are symmetrical. Okay. Now, let us I draw in here, because for understanding if I draw it here it will be very clear to you. Now, let us this is nothing but a my UGN, okay. Coming to the first junction, let us first junction is here, which is nothing but a I will first draw the junction and then I write down the signal flow. So, this is this way, this is this way, this is this way and this is this way. So, this I will write in red pen. So, this is nothing but a 1 minus R1, this is nothing but a 1 plus R1, this is R1, this is minus R1. Okay. Now, I have a UG, so I have a UG is here, UGN is coming to here and then there is a terminal at glottis which is nothing but a, so there will be z to the power, okay. So, let us there will be z to the power minus 1 delay, z to the power minus half, here will be delay z to the power minus half and this will be Rg and this will be 1 plus Rg divided by 2. Okay. And then the same junction I can continue, there will be a delay z to the power minus half, there will be a delay z to the power minus half and again there will be a junction. So, junction let us signal flow diagram, this is this, this is this, this is this, again this will be 1 minus R2, this will be 1 plus R2, this is R2, this is minus R2. Okay. Then I can say there will be again delay z to the power minus half, z to the power minus half. Okay. Again there will be a junction, let us this is nth junction, n minus 1 junction, there will be a junction, this is the let us n minus 1 junction. So, there will be a lot of junction in here. So, this if it is n minus 1 junction, this is 1 plus R n minus 1, this is 1 minus R n minus 1, this is R n minus 1, this is R n. Okay. And at the end lip there will be a boundary condition. So, there will be a z to the power minus 1, then I put the boundary condition which is like this, z to the power minus half, z to the power minus half, and this is nothing but a minus R L, this is 1 plus R L, I get U L n. Okay, this is the output. So, I have to find out u, if it is z domain, then u z u l z divided by u g z, that I have to find out. So, how do I find out? Let us calculate stage by stage. So, if I say any u, so you know that u k plus 1 plus z is nothing but a 1 plus r k, that we have already derived, 1 plus r k z to the power minus half u k z, u k plus z plus 1 z plus r k into u k plus 1 minus z, that we have derived last day. U k plus 1 z, the volume velocity which is injected in the k plus 1 tube is nothing but this one. Okay. From here I can find out what is u k plus z is nothing but in term of k plus 1 tube. So, it is nothing but a, so z to the power minus half, if I say it will come z to the power plus half divided by 1 plus r k into u k plus 1 plus z minus, this will become this side. So, minus r k z to the power half divided by 1 plus r k u k plus 1 minus z. Okay. So, this is, you can say u k plus z, u k plus z at kth tube u k plus z is nothing but this one. Okay. Similarly, I can find out what is u k minus z. Okay. So, what is u k minus z? Already we have done, u k minus z is nothing but a minus r k into u k minus r k into u k plus z into z to the power minus half plus 1 minus r k u k plus 1 minus z. This we have already done, already derived. Okay. So, from here I can say u k minus z is nothing but a minus r k z to the power minus half divided by 1 plus r k u k plus 1 plus z plus z to the power minus half 1 plus r k u k plus 1 minus z. Okay. I can do that k plus 1. So, I represent u k plus z, u k minus z in term of u k plus 1 z, u k plus 1 plus z, u k plus 1 minus z. Okay. Now, once I do that, then if you see here, this is my u k plus equation and this is my u k minus equation. Once I do that, now if you see that if I say matrix, this all are u k 1. So, u 1 plus, u 1 minus, the u 1 minus z, u 1 plus, u 1 minus z, you can see that blue and yellow. So, those are the equation. Now, if I say let us u k is nothing but a consist of 2 plus u k plus z and u k minus z. Whole u k is nothing but a forward wave and backward wave, and from here I can write u k is nothing but a r k into u k plus 1. If I write that, if you see this is the two equation u k minus and u k plus, u k. So, if it is u k plus 1 is nothing but a u k plus 1 plus z and u k plus 1 minus z. Okay. So, this has to be multiplied by this matrix equation. What is the matrix? Z to the power half divided by 1 plus r k minus r k into z to the power minus half, z to the power half divided by 1 plus r k, and another one is minus r k z to the power minus half divided by 1 plus r k, and z to the power minus half divided by 1 plus r k. So, those coefficient I write in matrix form. If I write this matrix form, okay, then I can say, I simplify this matrix, z to the power minus half 1 plus r k I can write down here. So, it is 1 minus r k divided by this one, 1 minus r k, 1 minus r k z to the power minus 1, z to the power minus 1. Now, if I see this matrix is r k cap and this whole matrix q k is equal to r k. So, I can write r k is nothing but a z to the power minus half. So, q k is equal to r k I can write. Okay. So, r k is nothing but a this one. Okay. Now, if it is that u k equal to r k into u k plus 1. So, if I say k varies from 1 to n, let us 0 to 1 to n, 1 to n, if I k varies with the 1 to n, then what will happen? Then u 1 I can say is nothing but a r 1, r 2, r 3 dot r n into u n minus 1, sorry u n plus 1. I can write k varies from 1 to n. Let us, if it is k varies from 1 to n, u 1 is nothing but a r 1, r 2, r 3 dot r n into u n plus 1. Okay. Now, if you see that this diagram, there is a n minus 1 symmetry junction. So, this is 1, 2 and this is n minus 1. Here the junction is not symmetry in RL cases, only problem is that there is a no backward wave in here. Let us I put a backward wave with 0. So, there will be a, I can put a backward wave here which is nothing but a 0. So, it is 1 minus R n, this is 1 plus R n, 1 plus R L, let us R L is equal to R n. So, it is 1 plus R n and this is minus R n, this is plus R n, this is minus R n, I can write. So, see this here in the slides, if you see I added this block. So, now there is a n number of block, instead of n minus 1 block I can get n number of block with input here backward wave is 0. So, I can write u n plus 1 is equal to nothing but a u L z and 0, because here u L z is only 0 is added with u L z. So, u L z plus and minus wave. So, I can write it is nothing but a 1 0 u L z. Okay. And u 1 equal to r 1, r 2, r 3 dot r n u n minus 1. So, it is nothing but a r 1, r 2, r 3 is dot r n into 1 0 u L z. Okay. Now, u 1 I get. Now, I have to find out what is the relation between u g z and u 1 z. So, I have to consider the boundary condition at the glottist. So, what is u g relation between the u g z and u 1 z? U g z. So, u 1 plus z is equal to 0.5 1 plus r g u g z plus r g u 1 minus z, I can write. So, I can say u g z is equal to 2 by 1 plus r g. So, 0.5 means, or you can write 0.5 by 1 plus r g. This is 2 by 1 plus r g, because this is half only. Okay. 2 by 1 plus r g u 1 plus z minus 2 r g by 1 plus r g u 1 minus z. So, I can say it is nothing but a 2 coefficient 2 by 1 plus r g 1 and another is 2 r g divided by 1 plus r g into u 1 z. Okay. So, u g z is nothing but a 2 by 1 plus r g, it is constant, it is nothing but a 1, this is minus, I think this is minus. So, it is minus r g into u 1 z. So, I can write u 1 is equal to r 1, r 2, r 3, r 4, r n into 1 0 u l z. So, I can write u g z is equal to r 1, r 2, r 3, sorry, u g z equal to 2 by 1 plus r g 1 minus r g. So, instead of u 1 z I can write r 1, r 2, r 3 dot 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 r n 1 0 u l z. Now, I get u g z divided by u l z is equal to 2 by 1 plus r g 1 minus r g r 1, r 2, r 3 dot 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 r n into 1 0. I can say that. So, which is nothing but a 1 by V z, 1 by the transfer function. So, V z I want to find out V z, which V z is equal to u l z divided by u g z. So, it is nothing but a 1 by V z. So, 1 by V z I can write in term of 2 by 1 plus r g 1 minus r g r 1, r 2, r 3, r n 1 0. Okay. Now, if I write that, then if I put the value of r 1 and r 2, the equation will becomes 2 by 1 plus r g 1 minus r g z to the power n by 2. So, if you see the r k is z to the power half. So, I can say if it is n, so it is z to the power n by 2 k equal to 1 to n 1 by 1 plus r k. R 1 z to the power minus half, for r 2 z to the power minus z to the power half, for r 3 z to, so if it is r n product of z to the power half, z to the power half, z to the power half, so n number of, so it is nothing but a z to the power n by 2 k equal to 1 to n 1 plus r k, k equal to 1 to n cap r k cap. So, r k is like the matrix is this and 1 0. So, now if I say my n is equal to 2, then I can find out the impulse or transfer function of the tube model. So, if I simplify this thing for 2 tube, if I consider that my length of the tube, the whole vocal cord is, vocal tract is simulated using 2 tube. So, if it is 2 tube, so n is equal to 2. If I put n equal to 2, then 1 by V z will become 2 by 1 plus r g will be same, this will be 1 minus r g will be there. So, there is no effect on here. Now, is z to the power n by 2, n equal to 2, so 2 by 2. Okay. Then product of k equal to 1 to n, k equal to 1 to n means n equal to 2. So, k instead of k equal to 1 to n, I can write 1 by 1 plus r 1 into 1 by 1 plus r 2. Okay. Then I can write k equal to 2 in this equation. So, k equal to 2, k equal to 1, 1 minus r 1, 1. So, I can write 1 minus r 1, another one is minus r 1 z to the power minus 1, z to the power minus 1 into 1 minus r 2 minus r 2 z to the power minus 1, z to the power minus 1, then 1 0. If I evaluate it, it will come. So, z to the power half z. So, z 2 z divided by 1 plus r g into 1 minus r g. This will be 1 by 1 plus r 1 into 1 plus r 2. Then I can matrix multiply this in this one. So, this one is 1 plus r 1 r 2 z to the power minus 1, 1 minus r 1 z to the power minus 1 minus r 2 z to the power minus 2. If I evaluate, so this matrix will be 1 0, I can say first evaluate this 2, then come to this here this side. Okay. So, if I write down the equation, then whole equation 1 by V z is nothing but a, I can multiply this thing 1 plus r 1 1 plus r 2 and this thing I can multiply together and I can find out. So, V z 1 by V z and then V z will becomes, if I derive these things and then the V z will become, V z will be 0.5 1 plus r g into 1 plus r 1 into 1 plus r 2 z to the power minus 1 divided by 1 plus r 1 r 2 plus r 1 r g z to the power minus 1 plus r 2 r g z to the power minus 2. This will be the two tube vocal tract model. If you see this transfer function, I have a 0 at origin z to the power minus 1, but I have a 2 pole. This is second order equation. So, I have a second order, we can say 2 pole or it is a second order equation. So, I have a single 0 for 2 tube model, I have a 0 at center, 1 0 and 2 pole. So, at origin 1 0 and 2 pole. So, if I have a n tube model, I can say n by 2 0 at origin and nth, this equation become n order. So, I can say there will be n number of pole, this equation become nth order. So, I can say this whole V z can be said this is all 0 are in center and this is all pole model. So, I can write V z is nothing but a g by d z, where d z is nothing but a pole model. So, if it is nth order, so it is nothing but a 1 plus k equal to 1 to n alpha k z to the power minus k. So, kth pole will nth pole will be the n number of pole will be there. So, I can write down the equation 1 plus k equal to 1 to n alpha k z to the power minus k and n by 2 0 at origin. So, instead of writing this the all 0 model, z to the power minus 1 minus half in here, z to the power minus half in here, I can write this dz in a signal flow diagram as a all pole model and z equal to this Vz z to the power minus, so all pole model, then it will be z to the power minus n by 2. So, I can write down the signal flow diagram in all pole model. So, I can say mathematically it is proved that a vocal tract transfer function can be simplified as a all pole digital filter. All pole digital filter I can simplify it. So, if I able to simplify all pole digital filter and if I know alpha k, which is nothing but in term of R1, R2 and the R1, R2, Rg I have to know. So, what is R1, R2? All are reflection coefficient. If I know all reflection coefficient, I can simulate this dz. So, it is impossible to implement this dz using digital filter. Okay. So, now I can say dz is nothing but a, there is a error in the slides, please correct it. Dz is nothing but a 1 plus k equal to 1 to n alpha k z to the power minus k. So, let us Rg is equal to 1, that means there is no glottal impedance Rg is equal to 1. Okay. Thank you.